Welcome everybody. I'm very excited to be here to talk with you. There's a recent development in technology referred to as bifacial panels, and I think they afford some really, really interesting opportunities for farmers who are interested in regenerative farming practices. And so that's kind of the bulk of what I'm going to talk about with you today. We are, of course, going to have I'll show you, briefly some other sort of novel implementations of traditional south-facing panels as well. Okay. When you hear solar panels on farms, an awful lot of people, like, this is what goes in their head. And this is awful and horrible in so many different ways. And I just want to reassure everybody that this is not what an agrivoltaic implementation of solar panels ought to look like. Next. So as I mentioned, there's this new, relatively new technology called bifacial photovoltaic panels. And what's interesting about these, the top picture that you see here is a traditional solar panel. And those are at a tilt angle that varies depending on your latitude on the earth. And we try to have them be as south-facing as possible. And this is typically what a traditional panel looks like in an agrivoltaic setting. And so you see in this particular case, these are in the top photo, you have beef cattle, and they're finishing on winter forage. The panel, and I'm kind of skipping ahead a little bit here, but the panel configuration you see here is very interesting because everybody immediately notices the gaps in the panels. And the reason this farm has gaps in the panels is they also grow, as a cash crop, they grow fresh market vegetables right underneath the panels. And so that gap affords you an opportunity to get a little bit, to get partial sun contact on the crop during that 10 to 2 critical period. And not the primary topic of today's conversation, but if anybody wants to talk about it a little more later in the Q&A, we can go back to it. Down below, you see some dairy cattle who are pasturing in their regular dairy pasture with the bifacial panels. And what makes them bifacial is that they generate electricity when the sun hits on either side of the panel. So they get morning sun, they generate electricity, and afternoon sun, they generate electricity. And if you're doing this over cash crop, you don't really lose very much productive square footage. So it's a really, really good option. This technology came out about 7 years ago. It's been widely studied in universities and ag programs over the last probably 4 years. And in the last 12 months and coming 12 months, a large number of universities have installed or are installing bifacial test fields. And so we're going to start to see a lot more research coming out. But one of the interesting things is when you grow these over cash crop, with the exception of tall cash crops, you don't see any negative impact to your yield or your productivity. And in some cases, you get a beneficial impact. The other thing that's nice about these is there are some really interesting partnership opportunities available for farms where you can get involved in a community scale generation project with very little money outlay on the farm's part, and create a really nice new income stream to your farm. And we're going to talk about some of those financial models a little bit later. Go ahead. And absolutely, if you have any questions whatsoever, you should, just feel free to unmute yourself and pop right in. This is a very, very techie, scary looking slide, but it answers a pretty obvious question, which is, if I got these big, tall, fences all over my pasture or all over my crop, first question is, they don't point up towards the sun. So do they make the same amount of energy as a traditional flat or tilt mounted panel? And what you're looking at here is the blue line is the traditional flat south-facing tilt-mounted panel on a test farm. And the gray line is bifacial panels mounted on the same test farm, same area. And one of the things you'll notice that's really interesting and surprising to a lot of people is the gray bifacial panel generation is as good or better pretty much universally throughout the year as a traditional tilted south-facing panel is. So that surprises a lot of people. But interestingly enough, you make just as much electricity and you make just as much money with the bifacial panels as you do traditional flat mounted. And if you need some nighttime reading because you're having trouble sleeping, I've given you the URL and the QR code, both there will go to that study if you want to get deep down in the weeds on that. Next. All right. So this is what bifacial panels look like. This particular field is a wheat field. And this particular set of bifacial panels, you'll notice the bottom panel is mounted fairly close to the ground. And we have two horizontal rows of panels. And so this is what that looks like. And you'll see we have cash crop planting right up very close to the panels themselves. And this would, in terms of regenerative farming, this would pretty typically be cash crop, cover crop rotation. This is the cash crop here, of course. And then you're going to go in and you're going to no-till, seed drill your cover crop for the winter. Anybody got any questions while we're here?
Margie, I have a question. When you're talking about the traditional flat mounted versus the vertical, is there a difference in cost to install?
If you look at a per panel cost, there's typically not really a substantial difference in cost to install. And now, when I say per panel cost, understand that, you're looking here at this screen and look where the vertical posts are, okay? So in between each pair of vertical posts, you have two panels, one on top and one on the bottom. And these bifacials tend to be larger than the traditional flat mounted panel. A traditional flat mounted panel is typically 2 feet by 4 feet or 3 feet by 4 feet. These are often 3 feet by 5 feet, 3 feet by 6 feet. So if you look at a per panel cost, you're going to go, wow, those bifacials are a lot more. But if you look at a per panel square foot of surface area cost, they're about the same. Now, individual rack mounts for the bifacial are more because I got more going on. But if you go back and you consider a traditional flat mounted, particularly if this were ground mounted south facing flat panel configuration, you would have twice as much racking required because those panels typically get mounted, one up. So you'd have the length of your solar panel array would be twice the length as it is here with this bifacial. So I definitely warn people, a lot of people like to get on the internet and they like to start looking at, costs of panels and stuff like that. Just be aware it's not an apples to oranges comparison if you're looking at individual equipment pricing or racking pricing. You really need to take a look at the installation cost for the total system. And they are generally, a bifacial system like this is going to cost you about the same amount per kilowatt of capacity. That's really what you want to look at when you're thinking about value on solar systems. They'll cost about the same per kilowatt of installed capacity as a traditional flat mounted south facing system.
Thanks.
Okay, next. Okay, so here's what it looks like at harvest time. So you've got your combine going through, and I like this picture for a couple of reasons. And the first question farmers always want to ask when they see pictures of bifacial panels is they go, how do I keep from smacking the panels with my equipment? And so the answer is, the GPS guidance system on your tractor is your friend, for sure. And the other thing is, you don't necessarily, first is generally, you do space the panels based on your equipment requirements. Now, in this particular case, they didn't plant as close to the bifacial panels as they could have. He could have kept more productive ground in place. But if you're going to follow, particularly if you're going to follow with livestock, backgrounding or finishing, and you're going to let them forage what's in there anyway, you don't necessarily need to be hypertensive about, covering every last possible square inch. So the amount of ground you're going to lose to non-planted surface area, this particular implementation, he's losing about 10%. But with GPS guided tracking, and when you do your first pass and disc it over, and you save those run coordinates as a program for your GPS, you can just come right on through again when you plant, right on through again when you harvest without any trouble and without any concerns about smacking the panels with your equipment. The other thing that's interesting about this particular implementation, this is cash crop, cover crop, and large animal forage. They do still have traditional fencing. And so these runs, and you'll see some runs like this in a couple slides later. These runs are, open at the ends, and, livestock come and go as they want. But we'll also see some implementations where you can actually use the panels as cross fencing. Next. And that's just another look at what it looks like, and yeah, it's real scary the first time you drive your $750,000 piece of equipment through your $2.5 million panel field. It's a cheek clenching moment for sure. But like I said, GPS in your tractor is your friend.
Do you have to worry about rocks getting spit up from the equipment? Hitting the panels?
Sure. Yeah. I mean, are you gonna clip a panel? Absolutely. But here's the thing with traditional mounted panels, every time it hails, you got to worry. Are you going to lose some cells on your panel every time you have a hailstorm? You absolutely are. Wind-blown acorns, do they, take out a 2 millimeter by 2 millimeter, donk on your panel? Absolutely. So, it's not, it's probably not the danger you think it is relative to the area loss you're going to have on traditional mounted panels. And these are a lot easier to maintain.
That brings me to a question I have. The strength of the panel and broadcast spreading, either manure or fertilizer inputs. Is that going to be an issue?
No, it's not. And so the way solar panels are built is you have a thin wafer of, a crystalline structure that's somewhat fragile. And if you're looking at these panels right here, the individual little navy blue squares, there's like 100 of them on each one of those panels. Those individual little navy blue squares, those are actually the little crystal wafers that are the photovoltaic material that make the electricity. They're mounted inside a clear, usually polycarbonate structure. So it's the same. It's generally the same material that your tractor window's made out of. It's the same material that safety glass is made out of. So, it's fairly robust stuff. If you sling a rock at it, there's a chance that you're going to get a little chip, the same way you would get a little chip out of, they call it a little spall. it'll spall just like your windshield spalls when you get when the car in front of you throws up a rock. You can get a little crack. Does that go completely through the polycarbonate coating? On occasion it does. What happens when that happens? You get some dirt intrusion and a little bit of water intrusion into that one little small navy blue square. And that navy blue square may or may not any longer generate PV. But panel manufacturers understand that this implementation in particular and panels in general need a certain level of robustness in order to be something people are willing to spend the money on. And you're looking at pictures of live systems. I mean, these pictures here, excuse me, these are not test farms. These are people who are actively farming. They're running equipment past, they're running seed drills, they're planting, they're harvesting. There's an interesting operation here in North America, just built recently in the United States. They actually crop corn. And they just accept that, during summer peak, they're not making a lot of electricity. And, they're going through and they're harvesting corn. So, and they're not having any trouble. Good question. Okay. Another nice thing, and if you're cash cropping with cereal or grains, and you're thinking about, or you are already planting a cover crop, it's kind of a big new thing right now. Go ahead on and let's add some meat, whether you're actually calving or lambing and raising them up, or whether you're just leasing your land out for backgrounding or finishing. There are a lot of really interesting cover crop mixes that you can fortify with things like rapeseed, a little bit of oat, things like that, that studies are now showing put on outstanding weight gain and meat quality in this kind of regenerative rotation. And that's perfectly compatible with panels, and I think everybody should do that. Everybody who's growing cereal grains ought to think about this at any rate, and see whether there's somebody in your area you can partner with to finish. And because I think this is a great income stream for farms who are cash cropping, cover cropping. Next. So this is what it kind of looks like. Now this is dairy. This is a dairy pasture, and they've got the bifacial panels. And here you wanted to see, you've got openings at the ends, and your stock is free to just come and go as they please, and they go do their own thing. And there they are. And one of the things I like about this picture is sometimes, particularly with beef cattle who tend to stand around a little bit more, you'll notice that the vast majority of the cows are all pointing one way. And that's a thing when you have stock with your solar panels, because the solar panels generate an electromagnetic field around them, which animals are sensitive to. Electromagnetic fields are what helps birds fly south for winter and north for the summer. And cows have a tendency, cows in particular, but sheep do it to some extent too, have a tendency to like to align themselves in a way so that they're all pointing in the most interesting feeling direction of the electromagnetic field. So here we have almost all of these cows are facing straight to the right in this photo. Next.
Do you have to worry about them rubbing against those panels?
When these panels first came out, and in fact, traditional solar panels as well, when they first came out, we were really worried about having stock intermixed in amongst them. And we used to run, a temporary wire around the fencing. And I think I actually have a photo of a farm. You'll be able to see metal posts that they have a single wire across outside of each of these each of these lines of panels. And for a while there was, in fact, there is still a equipment manufacturer who actually makes bolt-on cattle scratchers to go onto these posts, with the thinking being if they had a really nice, lovely scratching place, they wouldn't lean on the panel so much. But, actually in the end, it turns out that the stock don't really interact with the panels all that much, as long as they're not goats, I have to say. The way you do these panels is they take a steel, most people would call it an I-beam. It's actually something referred to as an H-column. They take a steel H-column, which is the same thing. They make foundations for large multi-story buildings, and they beat it into the ground with a pile driver. And then that's what these panels get mounted to. So those are not fence posts holding up these panels. They're substantive structural members, and they're designed to take the weight of the cows. Good question. Next. Okay, so this is an example of vertical panels being used in a multi-stage, multi-crop regenerative farming strategy, and being used as cross-fencing. So this particular farm, they grow a green forage cover to regenerate the soil. This particular farm grazes dairy cattle. So, and they're practicing intensive rotational grazing. So they've got the farm split up with several of these solar fences as they're cross fencing. So they start out with the regenerative cover crop. That cover crop, when it's ready, becomes forage, and they move dairy cows into the next section. Coming behind the dairy cows in that section are free range poultry. And then you go back and your green crop recovers. And so this is kind of, regenerative farming at its best, and a really good implementation for solar fencing. And the next slide has a pretty good picture of what that fencing looks like. Oh, I'm sorry. No. So this is what this commonly looks like when you're talking about cows. This particular implementation has a large fence space underneath. And in this case, it's not fenced because they're not coming through with small animals or poultry. You can see, if you look down near the grass line, next to each one of those vertical columns, you can see where that piling was beaten into the ground with the pile driver, and that constitutes the foundation. And there's a wide variety of range in not just panel thickness, but also in height, that I have the bottom of the panel on the ground, and then the height that I have the top panel on the ground. Do I put gaps in between the two runs of panels, or do I not? Your civil engineer is going to help you with all of these kinds of decisions and do what's best for you and for your particular kind of farming. Next slide.
Mark, I have a quick question.
Sure.
Have you ever seen these systems in a temporary format strung together on like wheels or something that's not totally ground fixed, I'll say?
That's a really good question. I have seen, I've only seen one, and I've got a photo of it I have in my regular photovoltaic slide deck. I have seen a traditional tilt-mounted panel array mounted on the solar panel equivalent of a chicken tracker. Yeah, they've got their racking is on sled runners, and they can hook the tractor up to it, and they can drag it around. And what they do is, they don't drag often. They go ahead and they ditch witch out a place for the cabling to go. They have a lot of extra cabling. They ditch witch out a place for the new cabling to go. They go ahead and bury it. Now they paid extra. So they've got, shielded encased cabling. They dump it down in the ditch witch, fill it back in. It sits there for 1 to 2 months, and then they pull the cable up and they move it and so forth. The highest tilt angle in the United States is about 40 degrees. So that's not even quite, as high as it is wide. Most implementations are around 30 degrees. So you don't have trouble with that thing becoming, a great big giant sail in the wind. Vertical panels, these bifacials, you really do need to have a structural support that holds these guys up, because the typical wind loading, in early spring and late fall or storm season that's required for a structure like this is pretty hefty. And so these are not really suitable as portable installations. And in this slide, you get a really good look at, you've got a variety, any kind of fencing you want to put underneath here to sort out any kind of stock you want to have interacting with this physical barrier is fine. And you can see there's that opening space. And in this particular case, they have these WWM panels that go in there. This also gives you a little bit better look at just sort of what the racking looks like and so forth. Next. Okay, and then this is what, a regenerative farming friendly traditional agrivoltaic setup looks like. And so I have the standard arrays that you would see in those, excuse me, in those big solar farms. Now, because these are up in the air, these typically are spaced. You typically have something in the order of 25 to 35 feet between those posts. And right smack center in this particular picture, you've got that one cow, and she is indeed leaning and scratching on that post. And so that's that. And even if you want to go traditional mount, if you're doing pasturing, or again, as I said, you're doing just cover cropping, forage in any kind of animal pasturing. This is also a possible opportunity for you. No trouble at all driving tractors under these. Next. All right. So the financial models that you have available for doing this stuff, there's two things you need to think about. And the first thing you need to think about is, there is obviously a non-trivial upfront cost to getting the system built. But that doesn't necessarily mean that the farm needs to pay out of pocket for the whole ticket. So that is one option, and that's that first bullet point on the left, getting the system built. You can purchase it, and you can pay for it with grants, the investment tax credit, your MAC-RS depreciation, and so forth. That's one way to do it. Now, if you don't need a lot of electricity yourself, and you're willing to have a fair amount of coverage with panels on your farm, there are a lot of utility companies right now, both private as well as the regular public utility, who would love you to host a panel system on your farm for them. And as part of the utilities requirement to generate, to renewably source particular portions of their generation portfolio, which in your area of the country here in New Jersey, that's been mandated by law. So your utility company will pay to put this stuff up for you. There are private companies who will pay to put this stuff up for you. And then there's a variety of ways you get paid. They lease the land from you. They participate in private purchase power agreements where you're generating the electricity and they promise to buy it from you for a particular amount that's usually a little less than what the electricity company is charging people and so forth. That leads us into, how do you monetize the power you create once you have the system up? And so what net metering, that first item, is intended that instead of paying the electric company for the electricity you use, you sell the electricity to them, and it all nets out in the end on your bill. That usually only works if you're a pretty hefty power user yourself. So you need to have a pretty hefty electric bill to do that. The other 3 bullet points here are different ways that other entities, either your electricity company or companies who build community solar projects and then sell the power, will pay you for the electricity being generated. Next. Okay, so if this is exciting and you're interested, your next step, the North Jersey RETA program, which Nate mentioned, will do a customized one-on-one personalized renewable energy assessment for your farm. We'll answer, a wide variety of different kinds of questions that you may have. That QR code down there on the left links to the program's webpage, where you can learn more about the program and more about what participation gets you. And if you just want to start talking to somebody right now about what solar would look like on your farm, use that blue QR code to the right, and it'll scroll down to the bottom of that page. And they'll collect a little bit of contact information from you, and you're started in the program. And the next slide is just my contact info if anybody wants it.
Great, thanks, Margie. We'll be handing it over to Dave now, who's going to talk about Rutgers Agrivoltaics program. So please hold questions till the end, but feel free to post them in the chat as you think of them, and we'll get to them at the end of the presentation. So Dave, whenever you're ready, you can get going.
Okay, great. Okay, so I'm Dave Specca, and I'm the project lead for the Rutgers Agrivoltaic program. We started an effort to do agrivoltaics at our research farms back in 2021, and we're fortunate enough to be able to get a state appropriation to be able to install these systems. Happy to report that now they've been built and are online, and we're getting ready this year to do our first season of crop trials. So what I'm going to do today is just to quickly go through our 3 farms that we have the systems installed on, quickly explain what type of system we're looking at and the crops that we want to grow there, and then a little bit more about vertical bifacials as well. It's certainly a system that we are very intrigued with as well at Rutgers, because of the way it addresses certain issues that other agrivoltaic systems have problems with. Let me see if I can advance these slides. Oh, now it doesn't seem to want to let me do that. Hang on. See if I can get it. There we go. Oops, go back one. I can go forward. I wonder if I can get backwards.
Can you see your presenter view on, do you have a dual screen on right now?
No. Let me see if the arrows are working. No, the arrows page up, maybe. I apologize. Hang on. Figure out a way to get backwards here.
It looks like you might have just had right-clicked, and I think I saw next previous.
Yeah.
Try right-clicking again.
Yep. Try right-clicking.
Yep.
So previous. Oh yeah.
Up
Yep.
top. There you go.
There we go. Sorry about that. So so this page is just showing you the location of the 3 farms. One up in North Hunterdon County is the Snyder Research and Extension Farm. You're probably familiar with that, right in your backyard. Also, location number 1 is the Cook Animal Farm on the main campus. That's where the vertical bifacials are located. And then the largest system is located down at our Rarick facility down near Bridgeton. I'll show you some pictures of that in just a second. So here's some photos of the Snyder farm. In this installation, we're looking at what are called single axis trackers. So those panels rotate on a center hub. That hub is 8 feet off the ground. And basically those panels in the program stay at a right angle to the sun through the day. So they basically follow the sun. The advantage of that right angle is that's the way to maximize the light interception and then the electrical output of each panel. This type of design tends to be the most efficient in terms of the number of kilowatt hours produced per kilowatt of panel installed. Another nice advantage to these is you can space these rows out just as far as you want, much like the vertical bifacials, and that the shadow tends to track across the field. So typically these rows run north and south, and then through the day, the shadows travel across the crop. So your lighting levels are much more uniform than it would be for something like a fixed south-facing panel. At the Snyder farm, we're looking at producing hay. In particular, it would be orchard grass. Since hay is a fairly large acreage crop in that part of the state, we thought that it would be appropriate to look at that first. So for the next 3 years, we'll be growing hay crops here. We're interested to see.
I'm good.
Yep. Hello. Okay, so we're interested to see how it would affect the hay production as well as the cutting and drying process, if there's some effect. The second location where we have the single axis tracker is in South Jersey. We have some of the single wide panels you can see in the top photo on the left that are very similar to what's up at the Snyder farm. Also, we have the double wide trackers, and they are at the same row spacing, but just twice as many panels. Those are typically in commercial grid scale projects, the ones that are being used, but it does really push the limit of the amount of shade that the crop will experience. Typically, in a solar farm, it takes between 4 and 5 acres to install 1 megawatt of capacity. In the single axis tracker system we have, it's about 6.3 acres per megawatt. On the double axis or double wide panels, it would be half that much or just over 3. So that's sort of really at the top end. We wanted to look at that extreme to see if we could modify the way that those panels track to allow more sun to reach the ground. So you can do actually go into the control program that these single axis trackers use and allow more sun to reach the crop by basically tilting the panels away from the sun. So you minimize the shade at times of the year when you need it. There's other times when you may want to maximize shade and have them parked even for things like frost protection. And so that is another option that these single axis trackers offer. At the Rarick farm, we'll be growing primarily vegetable crops on plastic mulch, and then cool season crops in the fall and spring like broccoli and spinach. Also, because of the large acreage of grain crops, especially soybeans grown in this part of the state, part of this system will be planted in soybeans. At each of the farms, there's 3 replications. So each system and the treatments involved in each system will be replicated 3 times. That'll allow us to go in and collect data and do very good statistical analysis on the data that's collected and be able to draw some pretty strong conclusions from that. Before I jump to the next picture, I just wanted to point out in the bottom photo, you'll see a post that's on the right side of the rows. That was installed to protect that conduit that's coming up to the panels. The manufacturer of this system really didn't anticipate heavy equipment running down the rows, but we felt that it was much too vulnerable to leave a conduit hanging out there with things like a heavy disc or a wagon or a plow coming alongside of it. So we installed these posts as an additional safety feature. I think in the future, probably we would have had them trench so that that conduit could come up along the first post and avoid having to add that bollard to it. But it's some of the things we've learned along the way. And that's one of the good things, is that we are accumulating this list of lessons learned that we'll be able to share with the growers when they're deciding what to do at their own facility, their own farm. This is a very recent photo of our vertical bifacial systems. Now, this is located on the main campus at the Rutgers Animal Farm. In this situation, we're looking at vertical bifacials on 20-foot wide rows and 40-foot wide rows. So that different spacing, as you saw in Margie's presentation, is up to the grower, depending on how wide their equipment is. But we are, again, trying to push the limit of the most dense what you would want to be, as well as a more reasonable spacing for larger farm equipment. Again, we have 3 replications, and so we'll begin planting the forage crop for this field in April, and then probably start putting the beef cows in here in the early fall. One thing I'll point out, one of the features of the vertical bifacials is that they can generate electricity on both sides, but one side tends to be less productive. That's the side where there's wires that are connecting from one panel to the next. And you'll notice in this photo how one row to the right is a dark, almost a black color. That's the primary high efficiency side at 100%. The grayer side is the side that produces, in our case, the panels we have at about 75%. And so the way you orient your panels, depending on their direction facing north and south, is important. Another interesting feature of the vertical bifacials is that in the middle of the day, when the sun is directly overhead, these panels are not receiving a lot of sunlight directly, but there's a lot of indirect light, especially in areas like New Jersey. There's a lot of cloud cover or upper level moisture that causes a lot of light to disperse. And so even when the sun's not striking the panels directly, they'll still be generating electricity because of that indirect light that's coming in from both sides. Another feature of having them oriented that way is that they tend to generate more power in the morning, not as much in the middle of the day, and again, more power in the afternoon. And that follows the demand curve of our grid more nicely than does the direct south-facing panels that tend to generate most of their power right at the peak of the day. And so we think that on the larger statewide scale, having the vertical bifacial systems installed will help the power companies to better balance the load on the grid, because of this additional power these will generate in the morning and again in the evening, when we tend to have our peaks in demand on the grid. So it's an interesting additional feature of these kinds of systems. So I guess that's about all I have on our system. I forgot to mention that we are going to raise beef cows here. And then in the winter months, when there's not enough forage for the meat, they'll be taken back to the barn and fed hay. And the systems are too small to be able to keep the animals isolated to one block. And so there will be open fence that will allow the animals to graze outside of the panels. Because of that, we're not going to be tracking so much the weight gain of the animals as much as we are the performance of the forage crops. That's what we're concerned with, how well they're growing in between the panels. And that's what we're going to be collecting our data on. We probably will have some tracking devices on the collars of the beef cows, so that through the day we can track where it is they spend most of their time, and see if that is something that is different than what we would normally see in an open field. Are they gathering in the shade in the afternoon and in the morning that it generates? Or are they staying out of the panels because they don't like that narrow arrangement and they'd rather be outside of that? That's some of what we hope to be able to see in that tracking that we do. I just wanted to pull up a couple other photos of vertical bifacial systems, since that's the focus of our discussion today. And this one is another one that is from a company located in Germany called Next to Sun, single axis or vertical bifacial rather, with dairy cows. And you can see here that they do have an electric fence with a post on the end, and then it's run up and down each side to keep the cows from rubbing against it. In our case, the clearance from the ground to the bottom of the panel is about 4 feet. Not quite high enough to allow cows to pass underneath, but certainly something like sheep could easily pass through there. We wouldn't need an electric wire in that case. Another application similar to what some of the photos that Margie had put up. These are double tall panels instead of 1 row of panels. It's 2. This is more typically being used. In our case, the panels are in a portrait orientation, so they're just as high as these double wides, and so you gather more electricity per row when you do it that way. There's some cost savings per kilowatt installed, but generally very nice systems. We're also interested and curious to see what it might do for protection from high winds. It's very common in South Jersey for farmers to plant strips of rye or actual perennial windbreaks to slow the wind down so you don't get as much sandblasting of the crop when it's young. And we think that these vertical bifacial panels may be able to serve that purpose as well and provide some additional benefit. I wanted to mention also the dual use solar energy pilot program, because this is an opportunity for our farmers to work with the Board of Public Utilities as well as private project developers and have these systems installed at your farm if it's a good location for solar. And I'll get into that in just a second. But here, this pilot program, the first applications will probably come out this fall. The total amount allowed over the next 3 years will be 200 megawatts, but it can be extended for 2 more years, adding 50 megawatts each time for a total of 300. Maximum project size is 10 megawatts. That's a whole lot more electricity than a farm would be able to use themselves. But the minimum size is probably going to be somewhere in the range of 500 kilowatts, which is still pretty big. So probably in addition to net metering, some community solar or grid supply projects will probably be involved with this program. The advantage of this program at the state level is not only do you get the SREC value, but you also can ask for an adder, some additional cost per megawatt of electricity produced, so that can help pay for any additional costs involved with having to space these things out further or additional wiring costs because of the wider spacing. But we do see it as really potentially a good, viable technology for farmers to look at because of the additional revenue stream that it would create in addition to the crops being grown. Sheep's on commercial solar farms. I just thought I'd put that up there because grazing small animals, we feel, should be allowed and designed for any solar installation, not just agrivoltaics, as well as native pollinator habitat. And I won't spend much time on this slide, but again, we've learned a lot of things along the way that we'll have printed in our extension publications, as well as things to discuss when we have open houses at the farms. But probably one of the most important things is your location. In rural areas, the local grid really is not designed to handle a lot of electricity. And because of that, a project may encounter significant upgrade costs to the grid to be able to export a lot of power. And that all has to be taken into account in your economics. So bottom line is it may not be economical depending on your location. So it's probably the farms that are closer to the more robust part of the grid, for instance, closer to urban areas, closer to warehouse facilities, closer to manufacturing facilities, that may be some of the earlier locations that would be most economical. But it is an important thing to consider in your system. And that's the end of my presentation. Thank you.